welcome back to my channel. Today we are going to look at the problem of sequences and series. We were given something here. They said for the given sequence 1, 6, 15, 28. Remember, we have different types of sequence or number pattern. We have the linear, we have the geometric, or the one that has a common ratio. We have the Fibonacci, where you have to use the last two values to get the next, and many of them. And we also have the quadratic. So whenever you're given any sequence, you have to check for all of them. We also have the one that is recursive. That will be for those that are actually going through the further studies mathematics. Now let's look at this. We have 1 to 6. If we check the common difference, which characterizes the linear or the arithmetic, we have all the common differences must be equal before we conclude. We have here 5, and then we have here 9. So definitely it's not linear, it's not arithmetic. We check common ratio. 6 divided by 1, remember is 10, 2 divided by 10, 1, then 3 divided by 10, 2. 6 divided by 1 is 6, 15 divided by 6 is not 6. So that will not apply. So let's check for second common difference, which characterizes the quadratic number pattern. If we have a second common difference, then that is quadratic number pattern. So let's see. We have 1, 6, 15, and 28. The first common difference for this man is 5, and 2 minus 10, 1. 15 minus 6 gives us a 9. And 28 minus 15 gives us a 13. First common difference, not equal. Let's try the next one. Second common difference, 9 minus 5 is 4. 13 minus this is also 4. Now, with this, we know that we are actually dealing with a quadratic number pattern because it has a common difference. Now, quadratic formula, as we know, is an squared plus bn plus c. So this will be the general formula for quadratic number pattern. So in order to get the general term, or the general formula, or what we call the nth term, in some cases, we have to first of all get the value of a, b, and c, and then solve it. Now we have a predefined formula. Then in due course, I'll also show us how we got to that formula. But at this stage, we are only just required to use it. So here we have that a plus b plus c will always be equal to our first term. Then we have 3a plus b will always be equal to our first term of the first difference. And then 2a will always be equal to the second difference. So with this, we can get our a, b, and c, sub it in, and then we can have our general term. Now we have, if we have that 2a is equals to 4, that means a will be equals to 4 divided by 2 is 2. We go up. Then remember 3a plus b is equals to 5. Then if we solve in 2, we have 3 times 2 plus b is equals to 5. That means b will be 5 minus 6 is minus 1. Then the last one, we have that a plus b plus c is equal to the first term of the sequence. Our a is 2, our b is -1, plus c is equal to 1. If we collect items, we have c will be 1 plus 1, 2 minus 2, 0. So our a, b, and c, we've gotten the values. All we need to do is to sub it into the quadratic formula. Please note, this is a quadratic formula. That's what we're using in place of number pattern. So when we sub in those, our c is 0, so we just sub in. So the general term for this number pattern will be Tn for any given term. We have our a 2n squared plus bn, which is minus 1. So I have minus n. C is 0. So this will be the general term for any term or any value in this sequence. So that is our generator. Now let's go to the second question. They are asking us to get the 20th term for this sequence. The 20th term for this sequence, it is always very easy once we've gotten our generator to calculate for anything. So our T20, based on our generator, is anywhere you see n, replace it with 20. So we have 20 all squared minus 20. 20 all squared minus 20. 20 times 20 is 400. 400 times 2 is 800. So I have 800 minus n minus 20, and that will give us 780. So the 20th step for this number pattern will be 780. Now the last question, they're asking us which term will be equals to 3,160. Which term will be equals to 3,160. So which term? Tn in this case is 3,160 is equals to 2n squared minus n. Now what we do is we simplify this. Write as a 0 or a standard form before you can proceed. So we have 2n squared minus n. This one over becomes minus 3160 equals to 0. Now let's simplify that and solve. Now if we divide all through by 2, no, 2 cannot go. Now let's look for terms. There are two ways. It's either we are looking for terms that we can use and factorize, or we go direct and plug it into the quadratic formula. Let's plug into quadratic formula. That is the surest way. We can factorize, but if you have very large numbers and you start dabbling into it and it gives you a problem, go straight into the quadratic formula. Says minus b. Our d in that case is negative 1 plus or minus square root of b squared. We have negative 1 all squared minus 4ac, 4ac all over 2a. That will give us the value of n. Now, what we must note is that n must be a positive integer because they are asking for the term number. And if they are asking for the term number, that term number must be a whole number, positive whole number, not a negative number or a fraction. It's like asking you the number of people. And remember, the number of people can never be half or negative. Number of people can never be half or negative. Now let's simplify this. Let's go on. We have negative is 1 plus or minus square root of. We have 2,5,281 all over 4. These will give us the two values of x. Now let's finish this. 2,5,281, the root is 159. So n can be 1 plus 159 over 4 or 1 minus 159 over 4. Remember that it must give you a plus or minus. You have to reject the one that is not applicable. So the first one gives us 160 divided by 4 and is going to give us 40. And then the next one gives us minus 158 divided by 4. Minus 158 divided by 4 will give us negative 39,5. Negative 39,5. Now, when we change these two values, Remember, like I said before, the number of terms that gives us this must be a whole number. So this will be our final answer. So term 40 is what will give us 3160. So this is how we work around quadratic number pattern. Please go through. If you have any query, if you have any question, do not relent to ask. I'm here to support. Have a blessed day.